This is the Czinger 21C. You won't have heard of it because it's a brand new car from a brand new company, but it's on a mission to change everything. On the face of it, sure, it's just another multi-million-dollar hypercar hopeful, except it's not. With 1,090 horsepower and weighing 1,090 kilograms, it's feather light and possesses that dream 1-to-1 power-to-weight ratio. The rear wheels are powered by a 930 horsepower 2.9 litre twin-turbo V8, the world's most power-dense engine. That spins to 11,000 RPM, while two electric motors on the front axle deliver another 160 horsepower and all-wheel drive. It uses a 7-speed sequential transmission and, get this, large chunks of the chassis are 3D printed. You'll notice too a one behind the other seating layout to keep the cockpit narrow and the driving position perfect. All this means truly face-bending performance. 0 to 60 miles an hour in 1.9 seconds, 0 to 100 miles an hour in 3.5, and a quarter mile in 8.5 seconds at 170 miles an hour. Oh, and a top speed of 220 miles an hour in track configuration, or over 270 miles an hour in low downforce setup. We've been invited to tour the factory and see just how radical the manufacturing process is for ourselves. This is how you build a 21C. Okay, so just a couple of bits that I wanted to show you inside the Czinger factory. It's all quite top secret, if I'm honest, so I'm not actually allowed inside this room, but in there is the world's only climate-controlled additive manufacturing facility. Basically, it's the big room where they do all the 3D printing, and the big news here is that they can produce aluminium printed parts now at the same rate that they can produce cast aluminium parts, which means price parity, and that's the big breakthrough. And over here, this is the big breakthrough on the manufacturing side. It's called the automated unit. It's basically a 15 meter by 15 meter space in which you can build up to 100,000 chassis a year. If you have a bigger factory, you could just multiply the number of these units that you have. So if you have 10 units, you could produce 100,000 chassis a year. The idea is it's doing away with the old production line techniques that date all the way back to Henry Ford. It's massively precise. It uses robots over here. The 3D parts get shipped in, and it's entirely flexible. The point is you could be building one type of car on a unit over here, you could have another unit over there producing another type of car, but then if you start selling more of one car than the other, then you can just switch over and start producing more of those. It's entirely flexible. It's all to do with the software. Whatever the computer says, then the robots will do. The future of car manufacturing. Okay, so here's where it gets quite interesting. This is what is underneath the skin of the 21C. In fact, this is actually an old chassis from back in 2017. The new chassis is on a poster on the wall over there. We'll get a shot of that and you can see it's quite significantly altered, but that's not the point. The point I want to show you is just how much of this car is actually 3D printed, and this does that job. So the clever part is in the parts that don't have complicated load profiles, you can just use simple aluminium extrusions, affordable, easy to work with. But then when the shapes get a bit more complicated, that's where the 3D printing comes in. So this, for example, is 3D printed aluminium, and you can see it just bolts together with other sections that lead into these straight aluminium extrusions. Come up here, and then things start to get a bit more complicated. So these things are called nodes, and you'll see they're joined together by just these straight standard carbon fiber poles. Again, affordable, easy to work with, but then they merge, they attach to these really organic shapes that are optimized for the loads that are being put through them. Speaking of organic shapes, down here you would have noticed the suspension, the control arms down here. They're absolutely beautiful, aren't they? That's because they're designed by computers to have only the amount of material that they need, and only the material in the places where they need it. So they take on these amazing shapes, a bit like a sort of sinewy human hand, isn't it? There's something about nature. It's like they planted this component and it's grown out the ground like this. Anyway, moving back down the car, carbon fiber roof section, because you can't 3D print everything. This here is actually 3D printed titanium rather than aluminium because it adds a bit of extra strength in the crucial A-pillar zone. And if we come around the front, this bumper section here is a really interesting component because it looks like normal aluminium, but this is all 3D printed, and inside it is a really complicated organic waffle honeycomb structure, whatever you want to call it, that's been designed by a computer and optimized to absorb crash loads. Unfortunately, I can't chop it open and show you what it looks like inside, but they do have a massive CAT scanner over there, so that's how they check whether 3D printed parts are as they should be internally. Interestingly, this car is supposedly quite hard to write off, because if you crash into a tree, you're probably going to bend the whole chassis and you need to replace the whole thing. But because it's modular, if this is the only bit that's damaged, well, you can replace that. And then you've got these aluminium extrusions, and then you've got a different section here. So with any luck, there's only a bit of the car that you need to stick back on. In fact, in true Blue Peter style, I've actually got some components here that I prepared earlier. Now, what I want to demonstrate here is, this is, if you like, 3 generations of the same component. So this one here was designed over the course of about 3 weeks by a team of human beings. Quite a lot of material, relatively heavy. And if we move along here, this was designed using slightly more advanced software, so you can feel it's actually hollow in there, so it's a little bit lighter and the shape is starting to get a bit more organic, isn't it? And finally, we have this, which is the latest iteration of the same part. So basically, it's got the same hard points, but this has been designed in 2 minutes by a computer. You'll notice it's much thinner, more spindly, it's more economical with the amount of material it's used. It feels super, super light. And this is really at the core of what the company's trying to achieve, that you don't need to spend hours poring over details. You put in the hard points, you put in your requirements into a computer, out pops the shape, and then you can print it. Look how thin that little section is there, but that's all you need for that particular part. It's amazing stuff. It's utterly beautiful as well. It's a shame, really, that you can't see more of it when the car's body's on top. Okay, time to meet the man behind Czinger Vehicles, founder and CEO, Kevin Czinger. Kevin?
Hey, Jack. Hey, welcome to the Team Czinger factory.
Thank you for having us. I tell you what, this is a pretty ballsy move, isn't it? You're taking on the established hypercars, the Bugatti Chirons and Aston Martin Valkyries of this world, with your first ever car. Did it have to be a hypercar? Why did you go in straight at the top?
Because this is a car that I've always dreamed of building. And if you have the tools to build something that's totally off the hook, go for it.
Just talk us through the design and why your vision was this layout. It had to look like this, right?
My vision is this layout because I love super bikes. I love biking itself. But being in that center driving position is not only the optimal position from a driving standpoint, handling standpoint, from an emotional standpoint, it's the optimal position. If you have the ability to express a vision, and this is a vision that combines art with technology, you've got to go for it.
It's certainly unlike anything I've ever seen. And just one thing, getting down onto the detail of the design, I read in some information I was given before that top speed 220 miles an hour in a kind of track configuration, but it could do, in theory, 270 in a kind of low downforce mode. So I'm assuming we've got the track configuration here, right?
You know, when you have the splitter and the wing and the configuration of the vehicle right now, you have 790 kilograms of downforce for a 1,090 kilogram vehicle. Okay. I love Bruce Lee. I'm not an Arnold Schwarzenegger guy. I think the 21st century is about being lean and mean and efficient and all about power to weight. Performance should be power to weight. So you need to take that downforce off, obviously, to get a higher speed.
Which is a perfect segue to talk about the powertrain a little bit.
Sure.
Because 2.88 litres twin turbo V8 producing on its own 930 horsepower. Where did the engine come from?
Well, it's a powertrain we've designed ourselves. It's part of an overall all-wheel drive system with an output of 1,090 horsepower.
Okay, so that's the hybrid element. So you've got this engine at the back driving the rear wheels, and then 2 more motors on the front axle?
That's correct, Jack. Yeah. So the way that this is set up is you have a super efficient 2.88 liter V8, 80 degree flat plane crank V8. in the rear, well, mid-engine, I would say. And in the front, you have 2 electric motors, torque vectoring of the front wheels. Each of those electric motors is powered by a small, very light 1 kilowatt-hour lithium titanate pack. So we took the highest discharge.
Whereabouts does that live? That battery, is it in the sills?
Those batteries are in the sills right here.
Yep.
And we use the highest discharge batteries, and we have them very small. We don't want to be a very heavy battery-powered car that loses charge.
It's not a plug-in hybrid you can drive 10 miles on EV alone. This is about enhancing the performance. So the way that you produce your chassis is unlike anyone else in the world, right? So there are 3D printed elements, nodes, if you like, with joining structures between them. Just talk a little bit about that.
We created our own tools. We looked at the auto industry and said, let's look at things from a clean sheet. Let's be technology agnostic. Let's look at all of the current technologies and combine those into a new production system, of which additive manufacturing is only one element. What I'd say really drives this is computing power. Because imagine that you can take a design, generate that design, run it through all of the engineering simulations necessary, and then be able to print that design. That means that you're only putting material where it's required, so it can be far lighter, far stronger, far durable, more durable than any other manufacturing technique. This vehicle is actually the first and ultimate instance in the 21st century of a totally revolutionary technology. This is $150 million of technology in this vehicle.
I want to have a look inside, actually.
Sure.
I want to see if I fit. Come on,
How's
you open the door, you do the honors.
Sure.
And look at the size of this door. This has to be, I could be entirely wrong, I'm sure the internet will correct me. Look at that. That has to be one of the longest doors in production, but it looks pretty amazing. Actually not
to make
heavy
this thing
at
happen.
all.
No, not at all.
Super light.
It's super light.
Thick,
so this is,
but it's all hollow
this is carbon fiber and
3D
printed aluminums and titaniums throughout the entire vehicle.
Okay. All right, I'm going to get in. Bum on the sill here. Swing my legs over. And slide in. Ah, wasn't too hard. Wasn't too hard at all.
No, not at all.
Nah.
It's very cool though, huh?
Yeah, I mean, it's actually not that hard to get in here.
No, it's not.
So many cars talk about like a cockpit feel, you know, you have like a center console that kind of locks you in, but having the doors so close to you, having the canopy over your head.
I mean, unique. Jack, imagine the emotion of sitting in the center of the car like that. And you get that mid-engine 930 horsepower at 11,000 RPM. Imagine the sound of that. You usually do something like this alone or, you know, with a partner.
Yeah.
Just like in a jet fighter. You want to have that cockpit look like a straight line cockpit.
All right, I'm going to get out. Should be simple. All right, so let's try out the back. Obviously, I don't plan on ever being a passenger in this thing. I only want to drive it.
I mean, if you got in from the other side, you know, obviously the belt's not there, so it's a lot easier.
Oh, that's quite interesting, actually.
No, I mean, look at how much room you have in this thing.
Yeah, because your legs wrap around the driver in the front. It feels very much like a motorbike in that respect. You could almost put your hands around there.
You bring your partner with it, and you're there.
This exhaust doesn't look like normal exhausts.
No.
Is that because it shoots X-shaped flames?
Yes. So those vanes allow the exhaust to come out in an X pattern. So the exhaust crosses in an X, just like you have the X-Men with superpowers. Here you have an X car with superpowers. And you know what? Wow. You know why it's an X? Because they spit zero emission flames.
What?
We run this car off of an M100, a methanol.
Yeah.
A methanol that's generated by taking CO2 out of the atmosphere, combining it with hydrogen using renewables, so that instead of having a battery store, renewable energy, sun, wind, hydro, you store it in a liquid. And that liquid has 30 times the energy density of a battery. Wow. So, because it's an internal combustion engine and methanol is in fact racing fuel, you can take that sustainably generated zero emission liquid and run it in this engine, or if you don't want to run it as a zero emission car, You can buy ethanol or you can buy regular racing
Regular
gasoline.
gas.
All burn in this car.
Wow.
We're going to launch the track vehicle, which can be certified also within the US to drive on the road.
Yeah.
And that's going to be followed by a fully homologated production vehicle, road vehicle.
So do you think early 2021 for sort of start of production?
For the track vehicles,
Yeah.
for the first 25 track vehicles,
Yeah.
then those are going to be followed a year or so later by another 65 vehicles
Okay.
that'll be fully homologated for North America and the EU, meaning fully crash certified.
Yeah, and road legal. So
Yep.
that's 80 cars in total.
Right.
Can you tell us the price?
Sure, it's $1.7 million US,
Yeah.
and that's before any packages or customization. And this will be a highly, highly customizable car.
Which in the context of Chiron's 2.5 million, Valkyrie's 2.5 plus, that's actually quite good value in this world of hypercars that we live in.
We think it is, and that's a good way to introduce our brand.
Yeah.
But this really does represent $150 million of technology development in something that I think personally, represents a revolution in human creativity that's about to take place.
Look, we know hypercar manufacturers turn up every week and most don't make it past the first press release and the first few dodgy renderings, but Czinger is a little bit different. For starters, it actually exists. I'm actually standing in the factory. It's actually got an order book. It's doing things significantly differently to everyone else. And look, it's not another all-electric hypercar with a power figure just plucked out of thin air. For now, I'd say I'm cautiously optimistic. All that's left is to drive the thing. And for that, watch this space.